Good afternoon, my dear students. Come back to our regular classes in vectors. In continuation to the yesterday's concept in vector algebra, so far we have concentrated on first four properties of this synopsis here. Today, I will give you a very important other synopsis point in vectors. Here, there is one important result in many problems. We use this case that is also taken as median property of these vectors. What is this median property? It's very simple concept in fact. Here, in any triangle ABC, just randomly choose one triangle ABC. If suppose we are taking two vectors from a vertex, AB bar, this AB bar plus AC bar. If AB bar plus AC bar if you are taking, then simply the result is nothing but twice the median vector passing through that particular vertex from where these two are taken. So this is called median property. Its proof is very simple here. Here AB bar plus AC bar equals to, just observe AB bar, suppose if this midpoint is D, then shall I write AB as A to D and D to B? AB bar written as AD bar plus DB bar. Similarly, AC bar written as AD bar plus DC bar. Then observe this, AD bar plus AD bar twice AD bar, and we know that D is the midpoint and DB, DC are equal vectors in opposite directions. That is why these two nullify each other, then simply you are getting back twice the vector AD bar. This is taken as the median property here. In many problems of competitive exams, we use very frequently this property to get the results in better way. That's why I prefer all of you to stick on to this important synopsis point compulsorily. Okay, I'll tell you simple examples how to use this effectively in solving very important questions. Even we can cut down the steps also to solve the problems if you are effectively using this one. Okay, randomly we can choose 2-3 problems here on this median property. And remember, we need not take triangle always. It is applicable for any 3 points which are non-collinear in the plane. Here, just anywhere, some x and y, if you are taking 2 points, and somewhere here we have a point P which is not collinear with these 2 points, then here Px bar and Py bar, Px bar plus Py bar is nothing but simply twice the vector joining P and midpoint of these two. This is what we call it as median property here. So this is called median property. By using this median property, we can do many problems very comfortably. As I told you, just let us check 2-3 problems based on this. Here, for example, randomly choose one quadrilateral A, B, C, D. It's a very standard problem in fact. You can find out this problem in almost every material here. In quadrilateral ABCD, normal quadrilateral ABCD, suppose this AC and BD midpoints are L and M. If the midpoints of diagonals AC and BD are L and M, then AB bar plus AD bar plus CB bar plus CD bar can be proved as equals to some K LM bar. Then what will be the value of this K? You can expect a question like this. Okay, here we can take them as A bar, B bar, C bar, D bar, and we can use the properties of quadrilateral in normal method, and applying this we may get the result in terms of L and M. That is general process we have. But if you remember this median property we can get it in better way, far better way by cutting down most of the steps in this calculations. Here, just observe the question what is given, AB bar plus AD bar plus CB bar plus CD bar equals to, we have to get the output in terms of LM bar. So, how is this possible? Let us check up. We require in terms of LM, I will come to that later. First of all, take this LHS in the equation given, AB bar and AD bar. In triangle ABD, observe it closely all of you here, in triangle ABD, AB bar plus AD bar, can I write it as twice AM bar by using our previous median property. Just now I told you this property. Now coming to this one, CB bar plus CD bar, for this I am using triangle CBD. In this triangle CBD, again CB bar plus CD bar equals to twice CM bar. So here twice AM bar plus twice CM bar will come. I am using median property twice here, once in triangle ABD and second time I am using median property in triangle CBD taken from vertex C. Now here in both of these, take 2 common, this is AM bar and this is CM bar. I am writing minus 2 of, just I am taking minus common. We know that here AB bar is written as minus of BA bar. If the direction is reversed, we can take minus sign here. That's why minus 2 of MA bar plus MC bar I am writing. You can guess comfortably here why I am writing so. MA bar, MC bar, MAC. So now choose the triangle MAC here. This triangle, MAC triangle, in MAC triangle, MA bar plus MC bar equals to twice the median through M. Median means joining M to the opposite midpoint. Opposite midpoint is L, we know already. So that's why here what you are getting, twice ML bar will come. So here minus 2 into minus 2, minus 4 ML bar or 4 times LM bar. That is why here simply K is replaced with 4. The right answer to this question is 4 here. So how simple to solve this problem? By using median property 3 times in 3 triangles. In triangle ABD I am using median property, in triangle CBD I am using median property, and again in triangle AMC also finally I am using median property. 3 steps, 3 times median property if you are applying, the result is here. How simple is this solution? Just you compare with any alternate method to this one. You never find any alternate method to this solution better than this one. So this is just an example how effectively we can utilize this median property to solve the problems. Not only this one, even I can give many more also. Just come back to one more standard important result. I prefer most of the problems solving that particular result. That's why I am giving much more importance to this particular case. Here, in a plane, here, suppose A, B, C, 3 points you choose which are non-collinear, they form obviously a triangle. In a triangle ABC, if P is a randomly chosen point, I am using again the word, in the plane of triangle ABC, P is a randomly chosen point, means P may be interior or P may be exterior or P may coincide with one of the vertices also, or it may lie on the sides also, does not matter. Here the thing is P is a point in the plane of triangle ABC. Then here we have a standard important result, PA bar plus PB bar plus PC bar equals to thrice the vector joining P with the centroid of this triangle. Here centroid, we know the centroid position, point of concurrence of the medians is called centroid. Somewhere here we have the centroid. So here PA bar plus PB bar plus PC bar equals to 3 times PG bar will come. This is applicable for any triangle, whatever the nature of the triangle, irrespective of that one. If P is a point in the plane of triangle ABC, then PA bar plus PB bar plus PC bar will be proved always as thrice PG bar, and it can be proved very comfortably by using median property. Okay, here take this LHS. Taking this LHS, now our target is to get thrice PG bar here. Now, observe it carefully. Out of these three vectors, keep any one vector as it is, that is your choice. Suppose PA bar I am keeping as it is, keep it aside. Now, PB bar plus PC bar, just observe the diagram once again. This is PB bar vector and this is PC bar vector. So, are you getting any idea immediately by observing this one? I am writing these two together. So, is there any relation for this step with our previous median property? Try to recollect immediately. PBC triangle in this, why don't we apply median property? Then PB plus PC bar equals to twice the median through P. Median means join to the midpoint of opposite side. Let us take this midpoint of side BC as some D, then shall I write it as twice PD bar by using median property in triangle PBC, PB bar plus PC bar equal to twice PD bar. So, this is the first step. Now, listen carefully. Here we have PA bar and here we have PD bar. You can enjoy vectors if you understand the basic concept, how we are moving step by step. Now, just observe, in this entire solution, here we do not have anywhere the term G, and after all we require the solution in terms of PG bar. So, the required term immediately in this is G. That is why here what I am doing, it is very simple. Suppose you are moving in vectors, here if you are moving from A to B and suppose you require in terms of G, A to B, how can you write it? A to G and G to B we can write simply. AB bar is written as AG bar plus GB bar. If you remember that basic idea, then simple to calculate this one. PA bar I am writing it as P to G and G to A. PA bar is written as, I want to move from P to A. Then what I am doing, instead of directly going from P to A, I am moving from P to G and G to A. What is wrong in this? So, simply PG bar plus GA bar, resultant is PA bar. I am writing like this. Plus twice, the same logic apply even to this case also, PD bar written as PG bar plus GD bar. Are you understanding the logic of this one? So, just every vector I am writing in terms of G bar, that is all. So, PG bar twice PG bar, thrice PG bar will be coming here. Now, GA bar plus twice GD bar, observe these two vectors. GA bar twice GD bar. What is this AD here? AD is called median, we know it. Okay, median is the line segment joining vertex and opposite midpoint. So, AD is median and we know that centroid divides the median, any median of triangle in how much, in what ratio? 2:1 ratio. So, therefore, centroid here is dividing AD in 2:1 ratio. So, that is clear. The ratio of these two line segments is very much clear here. Now, 3 PG bar as it is placed, just observe the directions. GA bar, this is GA bar, G to A it is moving, and twice GD bar. GD bar is facing this side. This is GD bar and this direction is GA bar. First of all, both the directions are opposite to each other, and regarding the magnitudes, twice this quantity, is it equal to this one or not? So, 2 times GD if you are taking, AG will come. If you take in the reverse direction, minus will come. Therefore, here GA bar and GD bar twice are equal to each other and opposite to each other in the directions. That's why they nullify each other. The result will be 0 bar here. Therefore, the result is how much you are getting? Thrice Pg bar will come. So this is the logic involved in solving this typical one by simply using our median property. I hope now you are enjoying the method of using this median effectively, much effectively than any other method here. Not even this one, even try to recollect some of the questions tested in previous IIT long back. I don't remember the exact year when it is tested, but it's a very standard problem. Almost in every book you will find this important one, whose solution is too lengthy one, and too complicated diagram also will be given to understand this one. Even 5-6 times if you practice this problem also, at the time when you are writing exam, I think more than 95% students will forget the actual methods. Okay, every time it will be a bit confusing one. Now today I am giving you one of the best methods to solve this particular problem. In a triangle ABC, randomly chosen a triangle ABC, suppose S is the circumcenter by natural usual notations I am using here. O is the orthocenter. Point of concurrence of altitudes is called orthocenter. Point of concurrence of perpendicular bisectors is called the circumcenter. So S and O are respectively circumcenter and orthocenter of a randomly chosen triangle ABC. In ABC triangle, here somewhere we have orthocenter and circumcenter. Then here we have to show that so many results we can be tested based on this one. One is SA bar plus SB bar plus SC bar equals to SO bar. Did you recollect this problem or not? It is one of the standard problems we have. And next, OA bar plus OB bar plus OC bar equals to twice OS bar. This is also a very important other problem can be tested on this here. Third one, even we can get different types of questions here. AO bar plus OB bar plus OC bar equals to twice AS bar. AS, circumradius. Twice the circumradius will become circumdiameter. That's why how they are testing is different here. The basic idea of solving this type of problems is very simple. Again, to solve this type of problems, typical conceptual problems, just simply I am using our median property based property. Just now we have, by using median property, I have derived a standard result. Okay, so why don't we utilize that one? So is it in the form of PA bar plus PB bar plus PC bar or not? That is why here I am using this previous technique, previous standard result here. Just now we have derived PA bar plus PB bar plus PC bar equals to thrice PG bar. Of course, in this problem, G is nowhere given, but we can eliminate G because luckily we have a relation between orthocenter, circumcenter and centroid. These three OGS, do you remember? OGS in any triangle are collinear here, and centroid divides orthocenter, circumcenter in what ratio? 2:1 ratio. This is called Euler's ratio, and the line segment, that line passing through all these three is called Euler's line. And of course, if you go little bit in depth, somewhere here we get N also, the 9-point circle center of 9-point circle, ONGS. All the four are collinear in general will come in any triangle, and in case of equilateral they will be coinciding. Okay, that's a different case. Now here clearly we have a relation for G, O and S. It is dividing in 2:1 ratio. If you remember that basic high school concept here, that's enough to solve this type of typical problems. Now, see here. Coming to first problem, SA bar plus SB bar plus SC bar equals to 3 times SG bar by using that result, because P is a randomly chosen point, and of course I am taking P as S here. Now, 3 SG bar, now I am writing it as 2 SG bar plus SG bar. 3 written as 2 plus 1, that is all. Here somewhere here we have 2, and it is in what ratio? 2:1 ratio, already you know it. Now, just observe this very carefully here. This SG bar direction is this, SG bar direction is this one. Now, if you are taking twice SG, if you double this SG, quantity is equals to GO or not. So, twice SG bar, why don't you write it as GO bar? Because SG and GO are same direction vectors, the only difference is magnitude. So, double this SG written as GO. Order is very, very important in vectors. Place SG bar as it is. Now, just observe it in reverse direction, first here and then here. Moving from S to G and G to O, S to G and G to O, is it SO totally or not in vectors terms? So, that is all, that is the solution here. You can compare any material, its general solution. Most of the books will give you a different approach which is lengthy, and not only lengthy, it is a confusing one also. Okay, after few days if you try to recollect, definitely you have to go through once again before doing this one. That is why I am giving a permanent solution. Even after 1 year also, if you try this basic idea, if you remember, we can get it very, very comfortably. This is the advantage of our median property and the result produced based on that one. Coming to second result, OA bar plus OB bar plus OC bar, obviously thrice OG bar. As the previous problem, write it as 2 OG bar plus OG bar, same 2 OG bar plus OG bar. Now, observe this, OG bar is double this GS bar or not. I am keeping 2 OG bar as it is, plus this OG bar is double this GS bar. So, why don't we write OG bar as twice GS bar? In both of these, 2 common factor, and O to G, G to S. So, is it OS bar or not? See the method of proving these 2 problems, both are similar way. In both, I am using the same technique here, but the only thing is Euler's ratio is applied effectively to get the results in better way, simple shortcut way here. Coming to third problem, AO bar plus OB bar plus OC bar. Because just now we have produced this second result, 2 terms in this second result are same here also or not. So, here what I am doing, AO bar as it is plus add another AO and OA. This OA bar, AO bar nullify each other because they are equal and opposite in direction, nullify each other. So, we are getting this result, AO bar twice AO bar plus this result we have proved just now is nothing but twice OS bar. So, 2 common in both, A to O and O to S, is it AS or not? Simply twice AS bar will come. Here we know it, here circle passing through all the 3 vertices is taken as circumcircle. In this circumcircle, this A to S is called radius vector. So, this is nothing but twice the radius vector will come, because it is twice the radius, we can also take it as diameter also through this A. If you are taking a diameter through A, that diameter will be nothing but twice AS bar. In vector terms I am saying here. So like this we can prove it as twice AS bar. See here, such important standard results also we can prove very comfortably by using our median property and the results based on median property. That's why you can understand the importance of this median property now in this vector. That's why I prefer to put it in synopsis points as one of the most important points of our synopsis. So this is about our next point in synopsis. Now let us move to one more important result. This is very important case. You know, collinearity and coplanarity conditions. We know if 3 points, 3 or any number of points, if they are lying on a straight line, then we can take them as collinear. And if the points are lying in, if 3 or more than 3 points are lying in a plane, we can be taking them as coplanar here. Now here already you know this collinearity and coplanarity conditions. Why should we discuss separately now? Because generally coplanarity conditions students will remember, and collinearity they will learn only one simple method, A bar and suppose B bar. If A bar and B bar are two parallel vectors, already I told you in the very first class definition, vectors are called free vectors also. If you are replacing this vector B bar as it is to here, then these two also becomes collinear. That's why if two vectors are either parallel or collinear, makes no difference here. What will be same? The vector directions are same in both. They are like vectors. If they are in opposite in direction, unlike vectors. Here they are like vectors or unlike vectors, but they are parallel or collinear. If they are collinear, they are differing only by what? Their magnitude. The direction is same here. That's why here we can take it as B bar equals to some lambda into A bar. Lambda is a non-zero constant. So if you multiply the length of this one with some other lambda, we will get the length of this one. Directions are same for both. That's why if two vectors A bar and B bar are either parallel or collinear, we can get simply A bar equal to lambda B bar or B bar equals to lambda A bar. This property generally will be remembered permanently by all students. Okay. Apart from this, we have one more method also we have for collinearity for 3 points. Before that, coming to coplanarity conditions, coplanarity here, if 3 vectors A bar, B bar, some C bar are lying on a plane or parallel to a plane. Parallel to a plane means coplanar. If A bar, B bar, C bar are here coplanar vectors, then they are linearly dependent. One is depending on the other two, or else technically they are called linearly dependent, or else mathematically if you want to write, there exists some x, y, z real numbers which are all not zeros simultaneously. If all zeros, what do you get? 0 equal to 0, nothing, result comes. So such that x A bar plus y B bar plus z C bar equals to 0. Okay, every student, okay, those who are having enough idea of fundamentals will remember this, no doubt. It's a standard theorem also in your +1, +2s. Now there is no confusion and nothing to discuss extra in this property. Okay, it's a standard result. Now what I am saying here, a very similar property we have even for the collinearity also. So okay, coming back to collinearity now. Collinearity. Suppose 3 points whose position vectors from origin with respect to origin here OA, OB, OC are respectively A bar, B bar, C bar. The position vectors of 3 points A, B, C are respectively A bar, B bar, C bar. Then the points are collinear if and only if the necessary and sufficient conditions, both the directions this should be same. There exists some real numbers x, y, z which are all not zeros simultaneously, such that x a bar plus y b bar plus z c bar equals to 0. It almost reflects this condition, but what is additionally we are getting, and x plus y plus z equals to 0 will come here in addition to that. So coplanarity, collinearity conditions will be almost looking same, but extra we get some of the coefficients also will come as 0. Here this is necessary and sufficient condition. If this condition is satisfied, they are collinear, and if they are collinear, they becomes this condition will be satisfied. Here how can you understand this concept? It's very simple one. See, we see the condition in both the ways. Suppose if they are collinear, A bar, B bar, C bar are collinear, then definitely one will divide the other two in certain ratio. Suppose B collinear with A and C, then B will divide AC in certain ratio, some take lambda is to 1. Then B bar will be, apply section formula, lambda C bar plus A bar by lambda plus 1 will come. If they are collinear, one will divide the other two in certain ratio, maybe internal or external. That's why I am taking randomly as lambda and 1 ratio. So A bar plus lambda C bar equals to lambda plus 1 into B bar, A bar minus of lambda plus 1 B bar plus lambda C bar equals to 0 will come. If they are taken as collinear points, now there exists some x, y, z in such a way that x a bar plus y b bar plus z c bar equals to 0, and x plus y plus z, x is a bar coefficient 1, here minus of lambda plus 1 plus lambda, is it 0 or not, check up. If we are taking the points as collinear, we are getting back this condition, x a bar plus y b bar plus z c bar equals to 0 and x plus y plus z equals to 0. Now conversely, if you think of the reverse direction, if you take the reverse direction, what happens? Let x a bar plus y b bar plus z c bar equals to 0, x plus y plus z equals to 0. This condition is given, then we have to show that these are collinear. So how is this possible now? X plus y plus z equal to 0, from this condition eliminate one variable, x a bar plus y b bar plus, in the place of z write minus of x plus y c bar equals to 0. Transfer this right side and transfer again x plus y to this side, we get x a bar plus y b bar by x plus y equals to c bar. That means c bar equals to, we are getting this, but it represents what? Is it in the form of m b bar plus n a bar by m plus n section formula or not? That means C is dividing this a bar and b bar in the ratio y is to x internally. C dividing a and c in y is to x internally means y is to x ratio. If the ratio is negative, it becomes external. If it is positive, it becomes internal. It's not the matter of internal or external, but here the matter is C is dividing AB in certain ratio. If it is dividing these two in ratio, definitely C is collinear with what? A and B will come. So that's the beauty of this concept here. If whenever 3 points A bar, B bar, C bar, whose position vectors are A bar, B bar, C bar are collinear, then there exist three real numbers which are all not simultaneously zeros x, y, z, such that this condition is satisfied. For coplanarity, this won't be applicable. X plus y plus z need not be 0, but for collinearity, compulsorily we get this condition as 0. So this is taken as our next property, might be 6th or 7th point, I don't remember exactly the number. So if you are taking this as important synopsis point now, how can the questions be tested on this concept? Okay, 2 minutes. Okay, here this collinearity and coplanarity. Okay, we do the one thing, all of you, just till now. So we can do this. We have completed till now here today, and tomorrow I'll give you examples. I want to give you some 2-3 better examples so that you can understand the better way how effectively we can utilize this particular property and why we are keeping it as a standard point in the synopsis. Okay, so today let us stop at this stage, and tomorrow we continue the class from here. Okay, hardly we have one more point to be covered in synopsis, then we see some previously tested questions. Okay, so thank you all, good evening. Okay, stay safe, stay home, see you tomorrow. Thank you.